Good morning, everyone, and welcome to today's webinar. My name is Jens Hellberg, and I'm the CEO of Truck Science. We're hosting this webinar in conjunction with NTA, and I extend a special welcome to all members joining us this morning. We partnered with NTA in 2019, and this partnership gives members access to our axle weight calculator at reduced rates. EVs and other alternative energy source vehicles have been around for a few years now, and the trucking industry has invested heavily in these technologies. Because of the complexity of the industry, however, with all of the different applications commercial vehicles are used for, there is still work to be done around infrastructure, range, engine power, and more. In this webinar, however, we'll focus on some of the weight implications of using these new technologies, and we'll be using two real-life examples to illustrate common scenarios where EVs are currently in use. We opted to go for two EVs rather than, say, a CNG example, as the overwhelming majority of inquiries we receive are about EVs. Depending on demand, vehicles using other energy sources could be the subject of a later webinar. So let's get started. First up, we'll be using a Peterbilt 520 EV with a garbage body, followed by a Lion Electric Lion 8 with a refrigerated body. Let's dive deeper into these scenarios using the Truck Science Axle Weight Calculator app. So we'll first design a garbage truck operating in California. So I'll set up the regulations. All 50 states are catered for at interstate level, and a lot of states are catered for at state road level, and we're constantly adding new ones on request. We've also recently released all of the Canadian provinces, so there's a wide range to choose from. For this example, I'll choose the Californian state roads. It's also possible to pin attributes of the vehicle we might be interested in during our build. In this case, I've pinned gross weight on the vehicle's front axle as a percentage, and the vehicle's gross as a percentage of GVWR and of permissible. We can also define ranges for particular attributes that our organization is comfortable with under organization standards. For safety and traction, we might have an internal limit we adhere to on gross weight on the vehicle's front axle. And I've already defined this range as between 20 and 100%, and we can define various other standards as well. But I'll save those settings for now. Now let's select our vehicle from the database of OEM specs. You'll see there's quite a wide range of vehicles to choose from, but as I said earlier, we'll take a Peterbilt 520 6x4. And we'll go for the EV spec. So let's familiarize ourselves with the workspace. So first up, on the left-hand side, we've been notified of a couple of things. Firstly, the front and rear chassis weights of the default spec have not been provided by the manufacturer. This varies between manufacturers. Some provide these weights on their bodybuilder portal, which we then include in the software, while others prefer that you get them directly from the dealer. We cater for either scenario, so I'll go ahead now and populate these weights from my spec. And the front axle is 14,200, and the rear axle is 8,300. Now you'll notice that the weights are quite a bit heavier than the equivalent diesel spec, and we'll see how that impacts the overall payload of the vehicle a bit later. I have another notification at the bottom left that this vehicle qualifies for an additional 2,000 pound weight increase overall in California. And we can see on the weights table that's already been added to the total permissible, which is now 52,000, where a diesel-powered vehicle for this particular overall bridge distance would be 50,000. Apart from the weights table on the right-hand side of the dashboard, on the left-hand side, we have our compliance indicators. These give us visual feedback on whether our design complies with what we call our 3 pillars of compliance: manufacturer's limits, regulatory compliance, and if I drill down to that, I can see I've specified those Californian state roads, and then organization standards. So organization standards, as I said, are internal quality or safety standards that are not enforced by law necessarily, but are nevertheless desirable metrics to implement on a build. As expected, all of these have green ticks next to them for the default spec. And just below these ticks, you can see those attributes that we pinned earlier in the settings. And I'll get back to those in a while. On the far left-hand side of the screen, there's a menu where you can drill down and change various elements of our build, add bodies, different items of equipment, trailers, and also payload. On the right-hand side, we can toggle through various views, say the bridge view, center of gravity view, turning radius. And we see now that the turning radius data has also not been supplied by the OEM on their bodybuilder portal. So I'll add this info from the spec sheet now. So that will be 83 inches, and the turning ability will be 40 degrees. And once that information has been populated, we can see the turning radius of the vehicle. And I'll get back to that a bit later on. I'll just toggle that back to our side view. Now, since this is going to be a vocational truck, and we don't have a traditional PTO from the transmission, we might need to add an ePTO to power the garbage body we're planning to add. The chassis provided by the dealer might well come with this pre-installed, but I'll add one for our example using one of our templates. So as you can see, there's a wide variety of equipment that one can add. I'll go ahead and select our other equipment template. If I had a DXF drawing of it, I could have imported that for a more realistic look. But the other equipment template will do fine for now. It'll do all the correct calculations provided the correct data has been populated. So I'll tweak those now, and I'll give it a name first of all. I'll call it my ePTO, and I'll go ahead and tweak those dimensions. And I'll tweak the weight. I'll set that to 250 pounds. And I'll go ahead and drag that on my chassis and place it on my chassis. As you can see, as I'm dragging there, the weights table updates automatically on the fly. So I'll go ahead and place it around about there. And you can see that the ePTO now has its own entry on the weights table with the weight distribution calculated. Next, we'll add a body. And I have the DXF drawing for this body that I'd like to add. So I can go ahead and choose that file from my desktop. And it's a rear loader that I'm going to add. And I walk through the wizard. I need to drag that body to the origin. And I can go ahead and specify the length, which is 279.6. The height will be auto-scaled according to the length, and I'll populate the width as well. And the weight at 14,700 pounds. The horizontal center of gravity of the body, I'll just specify that in inches, and that's going to be 151 inches from the front. The vertical center of gravity is around 30%, and lateral 50%. The payload center of gravity, again, I'll specify that in inches, and that's 103.5 from the front. So next I'll give it a name. I'll call it the rear loader 3,000. And I'll go ahead and save that and add it to my build. Now that's been saved to my personal library, and I can reuse that at a later time. But there are a number of options here. I can also share that with the rest of my team, with my distribution network, or even to all users of Truckside. So you're fully in control of the sharing properties of the data you add. So we can see from the weights table that the front axle here has been fully utilized. That's highlighted in blue and is marked as 100% utilized on the front, and that there is some excess capacity on the rear axle and on the total. And we just make a note of the payload there. The optimized payload is just under 14,000. And if I go ahead and just drag that to the rear, the table updates, and the payload jumps up to 14,350, and we are now taking full advantage of the extra 2,000 pound allowance in California. That 14,350 payload is not a bad payload. Up to now, the software has been auto-calculating the maximum legal payload, but just as an experiment, I'll just lock that payload in at 14,350. And let's just see what happens if we drag the body away from its optimized position. Immediately we become overloaded on manufacturer limits and on the regulation, no matter which way we go. So I'll go ahead and undo that change. Now that we've positioned the body, we need to reduce the afterframe to suit it. So let's cut the rear overhang, and I'll click on the rear overhang dimension, and I'll set that to 30 inches. And I'll also update the cab to body clearance in accordance with the manufacturer's recommendations. Set that to 45 inches. And now, if we look at the data points we pinned earlier, we can see that we are 100% utilizing the vehicle permissible, or the total permissible, but we are underutilizing the GVWR. So there's clearly some excess capacity there. So I'm just going to unlock that payload again and see what happens when if we change the regulations to somewhere less restrictive, say for instance Colorado. And if we bear in mind that the payload in California was 14,350 pounds. If I apply the Colorado state regulations, that jumps to 19,700, which is quite a big jump. And again, we are given an extra 2,000 pounds overall for an EV. Again, we see that the front axle is the limiting factor. So there's scope perhaps to up this payload, as there's still a bit of excess unused capacity on the rear and the total. So if I take this cab to body and I just move that back by a few inches, and bearing in mind our payload now is 19,700, once you move the vehicle back 2.5 inches, you get an extra 2,500 pounds of payload. And we are now pretty much maxing out on the front and maxing out on the rear axle. So that's a fairly serious payload of 22,000 pounds. Now, moving the body to the rear to gain more payload does not necessarily make operational sense, though, since this will increase the vehicle's swing out, which could become a safety issue for a truck operating in residential areas. So I'll go ahead and undo that. And because the vehicle is operating in residential areas, it also needs to be maneuverable. So having a small turning radius is desirable. The shorter the wheelbase, the smaller the turning radius. But the shorter the wheelbase, the smaller the weight allowance we'll get on bridge. So we've obviously gone ahead and populated those turning radius attributes. We can have a look at what that turning radius is and configure it as needed. This is always a bit of a trade-off, but in this case, we prevented from reducing the wheelbase too much further anyway because of the location of the battery on the chassis frame, and this can often be the case with EVs. So if we're happy with that vehicle, we can go ahead and print out a PDF for our customer, and this PDF contains all of the relevant views of the build, such as the side view, top view, center of gravity, whatever you decide is important, along with any notes or disclaimers and whatnot that you'd like to add. So before we move on to the next example, I just wanted to check in there with Martin whether we have any questions.
Yes, thank you, Jens. There's one question here about, the limit of the payload in the body. I mean, what we're calculating here is the maximum payload that the vehicle can carry without overloading the axles. But the question is, how do you know how much the body can actually hold in terms of, I suppose, the volume that the body has? That is something that you would most probably need to check with the body manufacturer to establish the exact density of the payload and the volume, to figure out whether that payload could even reach, say, 19,000 pounds. It might also be limited to less than that if the body is actually full based on the density of the material. So I'll also reply to that there, but there are a few questions coming through. So thanks for that. Keep those questions coming, and either we'll try and answer them here, or I'll just type a reply for you.
Okay, great. So for our next example, we'll design a refrigerated truck, again for use in California. So I'll go ahead and change those regulations again. We had them on Colorado, and I'll switch them back to California. And I'll leave the data points as they were on our previous build, as they'll be relevant here again. So we'll use a line electric 6x4, and we'll go for the line 8. And now that the default spec has been populated, you can see that the front and rear axle weights for these vehicles has been populated. So this OEM chooses to share those, and we then pre-populate them in the software for our users. Notice again that we've been given the extra 2,000 pound weight increase overall, and that's been applied on the total permissible in the weights table. Now we'll go ahead and add a box body, and we'll also add a refrigeration unit. So there are a few different makes and models here. I'll go for Thermo King T800. And we can immediately see that the unit will actually interfere with the cab. So we'll need to increase the height of the body to address this. So I'll just go ahead and click on the height dimension for the body, and I'll update that to 100 to address that issue. And to complete our configuration, I'll add a lift gate. And again, there are a few different makes to choose from, but I'll go ahead and select the Maxon, and I'll just scroll through the different options, and I'll take the Maxon GPT 25 tuckaway, and that completes our build. So we can take another look at the weights table, and we can see that the app has calculated the maximum payload here at about 17,500 pounds, and this is highlighted in blue. The other figure highlighted in blue is the 100% utilization of the rear axle, and you can see here that we aren't actually taking advantage of the extra 2,000 pounds allowed for EVs in California, since our total gross is only at 46,000. So we are maxing out on the rear axle and not utilizing that. So this is quite a common scenario with because of the heavier axle weights on EVs. And some states like Arizona have started allowing additional weight to be spread over the axles for EVs in addition to the overall weight. So let's try switching to Arizona and see what impact that has. Take note of the 52,000 permissible overall and the 34,000 on the rear. So if I go ahead and change that now to Arizona, that while the total permissible stays as it is in California, we get an extra 2,000 on the rear, and we get notified about that here on the left. So I'll clear that off, and you can immediately see then that we've got an extra around about 2,000 pounds of payload, which is bringing us up to 19,500. Interestingly, we are still not taking advantage of the overall allocation there. As our gross is now only about 48,500. The rear axle is still the limiting factor. So what would happen if we increased the rear axle allowance even further? And I can do that by just clicking on that the bridge or the permissible figure, and in this case we're limited by the bridge in Arizona, and I'll just increase that by 2,000 pounds to 38,000. And we can see that the payload jumps by another nearly 2,000 pounds. We're starting to take advantage of that extra 2,000 pound allowance overall, and we're maxing out on the rear. So if we push that up even further and make that 40,000 in line with the vehicle's GAWA, the payload then jumps up to 23,000. We're fully utilizing that overall permissible, and we're just about utilizing the rear axle permissible. So we eventually take advantage of most of the allowance, and the payload is up to 23,000, which is roughly what an equivalent diesel-powered vehicle might be able to carry. Any questions? Any more questions at this stage, Martin?
Yes, there was quite a good question, but it related to the garbage body application, but we can even demonstrate it with this particular body, and it had to do with the center of gravity of the payload. And the comment was that the center of gravity of the payload will change as the load increases on that body, and it'll obviously shift as the compaction takes place. So in reply to that, I've just said, you can obviously adjust the center of gravity of the payload manually and specify the payload of your choice. So if you want to make the payload 0 or change the payload, you can do that. Jens is showing that to you there. And you can also adjust the center of gravity of the payload. You can just keep it on the simple payload and just point out adjusting the payload and adjusting the center of gravity, especially the horizontal center of gravity, to demonstrate either the empty state of the body or the full state of the body if when that center of gravity moves as the vehicle gets loaded. Okay, thanks. That's all for now, Jens.
There is also an additional option here, which I haven't demonstrated. You're able to add individual items of payload. So if I were to add a few carcasses into my refrigerated body or whatever the case may be, I can go ahead and drag these and place them on the vehicle and calculate the payload in that way as well. So to sum up, here are a few things to consider when upfitting and utilizing EVs. To start with, the regulatory allowances for EVs vary significantly between states. So the jurisdiction where the vehicle is to be used is very important in the design process. Well,
Jens,
you have another question there, Martin.
Yes, I have a question as well, and you can probably share the slideshow to summarize it. But the question is, does the extra 2,000 pounds also apply to axle limits. Right now, the comment is that it only applies to the bridge formula, which is correct. In most states, and in terms of the federal regulations, the 2,000 pounds is applied to the overall bridge distance of the vehicle or the combination. That 2,000 pounds is not allocated to the axles. However, there are some states, and Jens, I think, showed that example now with one of the states, where they do allow the 2,000 pounds on the axles as well. But most states do not apply that to the axles. Okay. Jens.
Okay. There will also be an opportunity to ask more questions at I've just after this slide, so we can get back to a few more questions then. As Martin was referring to there, while states like Arizona already allow more weight to be spread over the axles as well as overall, upping the allowance over the axles even further would make EVs more competitive in terms of payload carrying capacity. While payload is not the only consideration, it certainly is an important one. Secondly, the vehicles are generally heavier than their diesel counterparts. Batteries are often spread across the chassis rail, moving the center of gravity further back and using up more of the rear axle weight allowance, as we saw in our second example. With the batteries being spread across the chassis rail, there's less space to play with for possible wheelbase and afterframe alterations, and less space to mount auxiliary equipment and bodies. And finally, without the traditional PTO from the transmission of a diesel engine, we may need to cater for an ePTO when speccing vocational vehicles. This also has an impact on weight and chassis rail space. So I've used the Truck Science axle weight calculator to work through the two examples today. If you'd like to try the app yourself, please visit truckscience.com to register for a fully functional free trial. You'll be up and running in under 5 minutes. Now, just before we wrap up, are there any more questions?
Yes, Jens, there's one more question here. Does this show the vertical center of gravity based on or limit based on the chassis OEM? So we do show the vertical center of gravity for the overall calculation and for each item. So we also have a vertical center of gravity for the chassis itself. In many cases, we have to estimate the vertical center of gravity because it's not something that's commonly provided by the manufacturers. But in terms of comparing it then to the OEM's limits, we are not doing that comparison at the moment. That is something that we will note down for future functionality, is that we get the information from the OEMs to make that comparison to show you when the vertical center of gravity exceeds the manufacturer's recommended maximum. Okay, thank you.
Okay, well, if there aren't any further questions, I'll end the webinar shortly. But before you go, please rate the webinar and leave any comments or questions you'd like to share with us. If you'd like to set up a personalized demo of that, just leave your contact details in the comments and we'll gladly set that up. Thanks for joining us today. We look forward to your feedback.